Since the first days when humans only knew the universe through the twinkling stars in the night sky, we have dreamed of exploring other planets. Mars, the red planet, has always been a distant but promising target. With its barren surface and harsh conditions, Mars was once considered the symbol of a lifeless world. But now, thanks to immense advancements in science and technology, the dream of building a new life on Mars is no longer a fantasy. The journey to conquer Mars is not just a scientific mission, but a symbol of human strength, creativity, and perseverance. To turn Mars into a place where humans can live, we must solve a series of major challenges. One of the most critical elements of this mission is building greenhouses, places that can create a living environment for plants and other life forms. These greenhouses will be the backbone of all agriculture and biology on Mars, helping maintain the supply of food and oxygen for humans, while protecting plants from the harsh conditions of the red planet. But to build strong and efficient greenhouses on Mars, the most important question is, what materials will we use to protect greenhouses from the harsh environmental impacts of Mars? Mars is a planet with extremely harsh environmental conditions compared to Earth. With its thin atmosphere, primarily composed of CO2, it is insufficient to support life as it does on Earth. Mars lacks a natural protective layer from cosmic radiation and ultraviolet rays from the sun. Moreover, cosmic and solar radiation is not shielded by a magnetic field, making survival on the planet's surface a massive challenge. The temperature on Mars is also a dangerous factor, with an average of around 60 degrees, and it can drop to as low as 125 degrees Celsius at the poles. This requires building materials for the greenhouse to have exceptional insulation properties, ensuring that the interior temperature remains warm enough for plants to grow. In addition, massive dust storms on Mars can last for months, covering the entire planet and exerting tremendous pressure on any structures we build there. However, the biggest challenge is cosmic radiation. When humans and plants are exposed to high levels of radiation, the risk of cancer, genetic mutations, and other diseases increases significantly. Therefore, greenhouses need to not only withstand dust storms and freezing temperatures, but also effectively block radiation. This requires extensive research into materials that can protect plants and life from Mars's hostile environment. To build greenhouses on Mars, we need materials that not only protect plants from radiation and provide warmth in freezing conditions, but are also lightweight, easy to transport, and capable of being regenerated or produced on site. The development of these materials will not only assist in building greenhouses, but also play a crucial role in expanding humanity's long-term settlement potential on the red planet. Polycarbonate, lightweight and durable material. Polycarbonate is one of the most advanced materials considered suitable for building greenhouses on Mars. Polycarbonate is lightweight, yet incredibly durable. It is a synthetic plastic with high resistance to mechanical impacts, such as strong winds and impacts. Most notably, polycarbonate is resistant to ultraviolet rays and allows light to pass through, which is vital to ensure that plants receive enough light for photosynthesis. The greatest advantage of polycarbonate is its superior heat resistance and durability compared to ordinary glass, while being much lighter. This helps reduce transportation costs from Earth to Mars. Additionally, this material can be easily shaped and assembled, making the construction of greenhouses quicker and more efficient. Under harsh conditions such as dust storms or high radiation, polycarbonate remains stable, making it an ideal choice for greenhouse walls and roofs. Aerogel, the perfect insulating material. When discussing the best insulation material for extreme temperatures on Mars, Aerogel cannot be overlooked. Aerogel is a super-light material primarily made up of air, with excellent insulating properties. Aerogel can keep the interior of the greenhouse warm throughout the cold nights on Mars, while protecting plants from sudden temperature changes during the day. Another amazing thing about Aerogel is its fire resistance and ability to withstand large pressure changes. This makes Aerogel not only ideal for insulation layers, but also usable in protecting plant-growing areas or other human-living systems on Mars. Even during long dust storms, Aerogel ensures that the temperature and environment inside the greenhouse remain stable. Graphene, the material of the future. Graphene is considered one of the most promising materials for future space projects, and it can play an important role in building greenhouses on Mars. Graphene is a form of carbon that is 200 times stronger than steel, but extremely lightweight, which optimizes transportation and assembly on Mars. Additionally, graphene has excellent electrical and heat conductivity, enabling it to integrate into solar energy systems and temperature control systems for the greenhouse. Not only that, but graphene also has excellent radiation shielding properties. With its ability to create a perfect shield for cosmic radiation, graphene can protect plants and equipment inside the greenhouse from harmful environmental impacts on Mars. This is especially crucial, as plants need not only light, but also protection from ultraviolet rays and other harmful radiation. Tempered glass, durable and transparent. Tempered glass, with much higher impact and heat resistance than regular glass, will be an ideal choice for the transparent surfaces of the greenhouse. Tempered glass's light transmission ability optimizes the photosynthesis process of plants, while its radiation-resistant coating on the surface ensures that harmful radiation cannot penetrate the greenhouse. Moreover, when tempered glass breaks, it does not form sharp shards, minimizing the risk of harm to humans and plants inside the greenhouse. The heat resistance of tempered glass also helps it withstand sudden temperature fluctuations on Mars, creating a safe and durable protective layer for the greenhouse. Heat and radiation-resistant composite materials, the ultimate shield. One of the greatest challenges in building greenhouses on Mars is the ability to resist cosmic radiation and extreme temperatures. Scientists have developed special composite materials, combining heat-resistant and radiation-shielding components to protect life inside the greenhouse from external environmental impacts. These composite materials will be used in the walls and roofs of the greenhouse, creating a strong and stable protective shield. The advantage of composite materials is their customizability and flexibility, allowing us to easily adjust them to meet specific requirements for each greenhouse area. With the integration of advanced technologies, composites not only protect plants, but also extend the greenhouse's lifespan, reducing future maintenance and repair costs. With these advanced materials, we are not just building greenhouses, but creating a complete ecosystem where plants can thrive in Mars's harsh conditions. These greenhouses will not only be places to grow plants, but also hubs for research, agricultural development, and biological studies. Temperature control and light management technologies will play a key role in optimizing the environment inside the greenhouse. The system of sensors will continuously monitor humidity, temperature, and light to ensure that plants always receive the best conditions for growth. Smart LED lights with adjustable wavelengths will be used to provide artificial light when sunlight is insufficient, especially during long dust storms. Additionally, The technology for water and nutrient circulation pumps will ensure that plants have a sufficient supply of nutrients to grow without the need for soil. Hydroponic and aeroponic systems will help conserve water and optimize growing space, allowing plants to grow faster and more efficiently. In the not-too-distant future, gigantic greenhouses will rise in the red sands of Mars. Green plants will bloom amid this barren planet, bringing life and hope to humanity. These greenhouses will not only be symbols of survival, but also symbols of belief and the ability to conquer the impossible. When future generations look up at Mars's fiery red sky, they will be proud that they have created a new home, a new world where humans and nature can coexist and thrive. Greenhouses will become the heart of life on Mars, providing food, oxygen, and hope for the generations to come. And with each new step, we are not only conquering Mars, but also opening up a bright future for humanity, where we are no longer limited by Earth. Mars will become home, and that will be proof of the strength of science, intelligence, and human perseverance. The mission to build greenhouses on Mars is one of the first steps in humanity's grand journey. The challenges we face only highlight the resilience and creativity of humanity. With advancements in science and technology, we have found optimal materials and solutions to protect life on the red planet. The vision of a green Mars is no longer far away. It is a near future, a future within our reach. We will achieve it, and when that day comes, we will look back with pride, knowing that we turned the impossible into reality. Mars will no longer be a barren planet. It will become humanity's new home, where life and hope always exist.